Aloha! Welcome to another episode of The Curvature Amateur. I'm your host, Louis Montaigne, and welcome to Hawaii, where I live on the Big Island. So we're not going to be looking at all the other islands today, we're just going to focus on the Big Island. So let's see what we're talking about. Oops. So today we're going to be looking at a pu'u. What is a pu'u? Is a little mound that sticks out like a sore thumb, and it's a crater. We have one here in orange. You can see how it sticks out in the middle of this flat land surrounding it. Okay. Now let's take a little look at the elevation of that place, because that's what we need to do when we calculate the earth curvature, to find out what kind of earth we live in. Do we live on a flat earth? I will show you that we don't. We have curvature. Do we live on the globe? I'm going to show you that the math to put us on the globe is far out of reality. Okay, so let's take a look at the elevation here of our pu'u, which is right next to this airport here, which is called Ellison, Onizuka. Hold on here. Who? Ellison, Onizuka. I thought I heard this name before. Where did I hear this name before? Question here. Are the crew of the exploded Challenger space shuttle still... What does Snopes have to say about that? Still what? In 1986? I remember that happening in 1986. I was in high school. And the teacher brought a TV screen in class, and we're so happy to see that we're going to be watching TV in class, just to show us this big explosion in red, and it looks like a big devil. Are the crew of the exploded Challenger space shuttle still alive? Wait a minute, who would doubt that? They showed it on TV. If they show it on TV, it must be true, no? The 7 astronauts supposedly killed in the 1986 Space Shuttle Challenger explosion are quietly living out their lives in the US. Somebody claims that. But what does Snopes say about that? Snopes reporting, "Bet it's false. No, it didn't happen. They must have died like people do when they go in through explosions." But wait a minute, Snopes is nice enough to show us what they're talking about here. Why would people doubt that? Huh? How would people still be alive after exploding? It looks a lot like them. Let's see. But who's this guy? Richard Scobie or Richard Scobie? He kind of looks a lot like the same guy, looking at his lost eyes. Looks like he just popped out of a kombucha bottle. While you stay home. Jeez. Okay, what else they gotta show us on Snopes? How about this guy here, Ronald McNair? Is he Carl McNair? Did the guy turn into him? Look, is his eye, kind of. His other eye, kind of. His cheeks, his nose, his teeth look different. But kind of looks the same to me. Oh, who we got here? Ellison Onizuka. Ellison and Claude. You say Claude in English, but it's Claude. The French way of pronouncing this French word is Claude. Claude Onizuka. Is it the same guy? Did he age into that? Look at the eyes, kind of. The eyes, kind of, yeah. The nose, kind of. The forehead looks a little rounder, but maybe you got a little skinnier. Hairline close. Big ear close. What is it? The chin? Would it be him? Would he fake his life like that? Judith Resnick. She looks a lot like the same person, doesn't she? Maybe a little different. Who would do that to their own name? Sharon Krista McAuliffe. That looks different, but maybe not. You have any more of those guys? Hey, Mr. Snopes, you have any advertisement for selling children on Wayfair? Is Wayfair trafficking children? Didn't you advertise for Wayfair, Snopes? Where's your Wayfair advertisement today? Did you just delete it or what? Anyway, we're not making a video about that. We're gonna be going back to our elevation map here, like nice people, and make sure we don't live on a globe. So let's go see. Wait a minute, I want a real image here. Satellite image. Thank you. So let's go take a look at our Pu'u Ku'ili by the Ellison Onizuka Airport. Right down here. See it? Zoom in. Here it is. A little bit closer. A bit more close. No, we don't need that close. Here we go. So here's our Pu'u. You can see the top here is a little caved in, like a crater. And let's look at the tallest point, the highest point of elevation on that Pu'u. It says 311 feet. Let's see what they say here. 311 again. 282. 285. 285. 349. 282. So it looks like 311 was our highest point. Okay, 311. Should we stick with that? Let's look on this low part that dips here, because the Pu'u is tall, 311 feet, and the highway stands about the same height of elevation. See the highway here? When we drive on the highway, we can see the top of the Pu'u. It looks like we're about the same height. So let's look at the low spot right above the Pu'u. 213. 213. 213 again. 213. So we're basically 100 feet lower than the top of the Pu'u, right there at its feet. And as we keep going towards the highway, it gets a little higher and higher and higher, climbing up the slopes of Hualalai Mountain. Okay, so we get the idea. 311 feet, 213, about 100 feet difference. Okay, so why do we check that? We have to check our measurements, see the height and the distance. Let's look at the distance of our calculating our Earth calculating our Earth curvature. So we're zooming out here to show you where I was observing that from. Let's turn it this way a little bit, fit it more on the screen. So we're going to be observing our Pu'u, which is over here, from Kauai High, which exactly at Spencer Beach Park. And we're also going to be observing it from Lapakahi here next to Mahukona. Okay, so a little bit bigger, just a bit like that. Okay, let's measure the distance. Our Pu'u is the orange spot here. Measure distance, please. 2 Spencer Beach Park, which is kind of hidden by this word here. So we get 19.82 miles of distance between the two. Okay, how to calculate the Earth curvature? There's a lot of websites about that. Some, they give you the answer right away. This is how much you'll be losing of the ground level if you are at certain distances. And several sites, they calculate it for you, some in miles, some in kilometers. My favorite one is this one right here. Why? Because it has a drawing. And the drawing is a simple way to help us understand what we're talking about here when we're dealing with all these numbers. So Robert is the expert here, was asked by other people at all levels. So how can I find the curvature per mile of the Earth's surface? Okay, so in 1 mile, so he started off with 1 mile, 1. And he used the Pythagoras triangle, a squared plus b squared equals c squared. And we all know that squaring 1 is 1. The answer is 1. Okay, so he started off with this number here too, 3,963 miles, which is supposed to be the radius of our Earth. If we're on a ball, a globe, like they say, we're spinning in space around the sun, and the sun is moving forward across the space, but somehow we still see the stars not moving from night to night, year to year, other than the planets. We do not see stars move. So yes, he used this precise number, 3,963 miles. No decimals behind, a straight up number. He didn't round it off to 4,000 miles, didn't round it off to 3,900 miles, not even 3,960 miles. There's a little 3 at the end to add precision. Okay, and this was precision. They got the answer of 7.98 inches in after 1 mile of distance. Okay, so it's approximately 8 inches in 1 mile. But if we understand the math well, you can look up other websites. It's all the same. It's 8 inches per mile squared. We got to square the distance. We measure the distance in miles or kilometers, but the formula is 8 inches per mile squared. So the distance, we square that number. All right. Let's pull our calculator out here and give us a little understanding what we're talking about. Everybody knows the value of 2/3. 2 divided by 3 is 0.6 periodical. Okay, 8 inches in a foot is the same value, 2/3, 0.6 periodical. Okay, now I want to know what is 7.98 inches. Who puts decimals in inches? I don't know. How many in 1 foot? What's the proportion of that? Makes 0.665, just a tiny bit less than the value of 2/3. All right, let's keep that in mind. Now we're going to go to our map here, look at our distance. Get the calculator back out again. Okay, so we have our distance is 19.82 miles. We got to square that number, multiply it by itself. So we get 392, and we multiply that by 0.665. So we get 261 feet of elevation. You understand? Should we do it again? 19.82 miles of distance. Okay, the miles of distance, we square that. We multiply it by the same number. Okay, and then we multiply that answer by a bit less than 2/3, 0.665 to be accurate. You can use 2/3 if you want. So we get 261 feet. We should not be able to see anything. If my camera eye is at the ocean level here, I shouldn't be able to see anything below 261 feet. Okay, let's see how accurate that is. Might be accurate, might be not. Let's see what I'm talking about here. So first I went up on the highway above Spencer Beach Park, And I brought my altimeter. It says 321 feet of elevation. That's the highway going up towards Waimea. And I'm looking towards Hualalai Mountain and our Pu'u Ku'ili by the Claude Onizuka Airport. Alright, so let's take a quick look at it. You see the top of the Pu'u clearly. Okay, remember this is 311 feet of elevation, and down here is about 100 feet less, which is 213 feet of elevation according to the elevation finding website. Okay, you might be able to notice like 3 buildings in white here. Might be able to see that later on. And if you estimate, so this is about 100 feet, and that's about 200 feet. Does that make sense? 1, 2, 3. Yeah, it makes sense to me. Okay, let's keep looking a little bit, see what kind of details we can see from higher up. You can see the waves splashing in white. They're splashing against the rocks on the shoreline. So you can clearly see the shoreline that far away. You can see the sand on the beach and clearly see the treetops and the black rocks of the lava streaks. Okay, you get the picture. Now let's go take a look at what we see from Spencer Beach Park. Okay, you got it? Too much zooming. Anyway, from Spencer Beach, what does it look down there? Nice little easy to park place, and walk right up to the beach, and you can find some friends there. And there's some tennis courts, basketball courts. You can take your shower, you can camp there. We went there to pick some dates one year, but since somebody saw us pick dates, they decided to cut all the date palms and not let anybody eat dates from the trees in a public park. Come on. Anyway, that's what it looks like, but that's not what I want to show you about our Earth curvature. I walk a little further on the sand, walk down the beach for you. With my camera, my Nikon P900, and we're looking towards our Pu'u Ku'ili by the Ellison Onizuka Airport. Claude's brother. I watched a video a long time ago talking about those astronauts, and somehow there was a part of the story where after Ellison died, his brother Claude went over and just to cheer up his wife, Ellison's wife, decided to marry his brother's wife. And it was so wonderful for her that it was as if he never left. It was the same hard-on, the same guy, pretty much the same bank account. Anyway, so I'm trying to sit down on the beach here gracefully. Let's cut the wind, please. Okay, sorry if I'm wobbling. I'm sitting down slowly on the beach, trying to get the camera lens as close to the water as possible without dipping my camera or getting a little splash on my camera from the salt water. It would be terrible. So anyway, as I'm getting this thing closest to the water possible, I made Pu'u Ku'ili turn into an island. Just to prove to you here that the world is not flat. It is not flat. It might be flatter than a globe, that's for sure, but it is not flat. It's not flatter than a pancake either. Not a pancake either. Pancake either. Sorry about my French-Canadian accent. We do what we can. So, if we remember our mat here, pulling out our calculator. So I shouldn't be able to see anything below 261 feet. The top of the Pu'u is 311 feet, and I'm not seeing the ground here, which is 213 feet. So it kind of makes sense. You could say that, yes, the globe theory, globe math here is right, and you're too stupid, Louis. You're questioning it while it's reality, and you're wrong, and all the other flat earthers are wrong. Well, okay, you might say I'm wrong, I'm off the track here, I'm stupid if you want, but I have more to show you. Keep watching this video and you'll see more. Hi, guy. So, yes, I have plenty of evidence. Not just this one here. So as I'm standing up on my feet, I'm connecting that island. You see? I'm regaining the 213 feet of elevation here just by standing up. And I only measure 5 feet 8. How much curvature is hiding this? How much land is getting hidden? It's hard to say. But I'm standing up. My feet are basically touching water here. You can see how flat this beach is. I'm trying not to look at other people making part of my video. So I went up about a foot, and you can see a whole lot more land popping up. Okay, I'm going to keep on climbing a little bit more. Walk away from the water, step up 6 inches here, and another 6 inches there. Let me skip along a little bit because I don't want to waste too much time. Keep walking, keep looking back. I keep climbing a couple more feet, and we're gaining a lot of land at the other end. And I'm going to turn around and climb up this bank here, close to the driveway into the park. Standing right next to the bougainvilleas, which make great hedges if you need to keep anybody out of your yard. They got lots of thorns, and they flower pretty much year round. They have different colors of flowers. And let's look back at our Pu'u from about maybe 15 feet higher up. You can see a lot more land. A lot more land. We don't see the whole shoreline. Don't see the beaches anymore. But we see a lot more land. What am I proving here? Well, let's keep going. We're going to go to our next observation spot. First, let's go see on our map here where it is. We're going to Lapakahi, next to Mahukona on the Kohala coast. Here is Lapakahi. And right around here, we have a little lighthouse. You can see its shadow. Zoom in a little bit more. Okay, so I climbed down here, and I went up on the hill about here, and then I'm going to finish off right on the entrance of the parking lot of the state park, which is closed right now. Why do they need to close the park right now? You tell me why. look at the elevation of these places. Move away from there. A bit more. Go down the coast. Somewhere around here. Yeah, here's Mahukona and Lapakahi. Mahukona, Lapakahi. Okay, let's go look a little closer. The ground's there. So according to this website, let's look at this elevation here. You can tell that the lighthouse is here with the little shadow. It says 29 feet. 29 feet. 29. 42, that's higher up. So, all right, we're about 30 feet. So remember this number, 30 feet, which is our lighthouse. Now let's go a little further. In the entrance of the state park, at the gate, they need to keep the gate closed. This park that very few people ever visit throughout the day, full of sunlight, no virus would survive there. To go to the ocean water, sea water, which is very good cure for just about anything. But no, they're not going to let anybody go there. In a healthy environment. So the elevation here where I was parked is 125 feet. Excuse me. 125 feet here and 30 feet by the lighthouse. Okay? Now, let's take the measurement of the distance between here and our Pu'u Ku'ili. So it's about here somewhere. And our Pu'u Ku'ili is here. Can I make it a little bit bigger? Fit it in one screen. Yeah, I can fit it in one screen. Is it here? Let's look again just to be accurate. Just to be accurate. Is it this point here? Yeah. See, it's right next to this green one, Mahukona. A little bit broader. Not too broad. Do we fit it? Do we fit it? I think we do. Yep, we do. Okay, from left to right on the screen, let's measure the distance between Pu'u Ku'ili and Lapakahi. 27.54 miles. Okay, let's pull out our calculator again. Clear. 27.54 miles. We square that number. The distance needs to be squared. 758. Then we multiply that by a bit less than 2/3, 0.665. So we are not supposed to see anything below 504 feet at the distance of 27.54 miles. 504 feet. Okay? Let's see what I'm talking about here. So I brought my altimeter and I reset it at 0 right above the water level. See, it goes from 0 to 3 feet. Okay, I even got a little splash on my butt here, got a little splash on my tripod. Luckily it didn't hit my camera. And we're looking towards Pu'u Ku'ili. What do we see out there? Is there anything noticeable out from the ocean level? Looking 27 miles away, and I'm not supposed to see anything below 500 feet or so. Does that make any sense? Yeah, I do not see Pu'u Ku'ili, which stands at 311 feet tall, and I'm at all this distance, and I'm not supposed to see anything below 500 feet. Look at this beautiful water here, makes you want to dive right in. So I'm keeping the camera recording, and I'm going to climb up a little bit just to show you what we see. Looking at Pu'u Ku'ili. I'm going to skip along a little bit because, oh, hold on, I just want to show you this first. Too fast. Going up. Yeah, I wanted to look here, but I noticed my altimeter didn't change going up like 3 feet. You can tell we're still pretty close to the water. So, all right, never mind. I'll go a little higher up. So you can see our lighthouse here right above. You can see it's about 30 feet from the water level up to there. I gotta step up these jagged rocks. Nobody thought of making a path on those rocks. Here's a little spot here. I can go make another observation. And turning the camera around towards Pu'u Ku'ili, the slopes of Hualalai, by the Kona airport called Ellison Onezaka. It's a Honezaka. Sorry, excuse my French. Those Freemasons, they have all kinds of funny names. So I'm up at 13 feet of elevation here on this rock. Okay. Yes, Freemasons. In order to be an astronaut, be part of the NASA crew members, you gotta earn your 33rd degree of Freemasonhood. Okay, looking out there, what do I see? I'm at 13 feet of elevation. Whoops! What is this here? What is this? Is that the top of our Pu'u? Is it appearing? You see it? Right here. Kind of hard to see. You need to have a big clear screen to see that. Sorry if you have your little dinky phone. You see it again? Right here. Top of our Pu'u, which stands 311 feet above the ocean level. And at that distance, I'm not supposed to see. It's over here now. I'm not supposed to see anything below 500 feet. And I just went up. 13 feet, says my altimeter. So I didn't take time to set my tripod very well to make it level. You see the shoreline here. And our curving water is eclipsing part of the ground and where is the Pu'u top? Somewhere over here. I zoomed out a little bit so we don't see it as well. But anyway, we saw it, didn't we? I'm just 13 feet up here. I'm not supposed to see anything under 500 feet in such a distance. Remember our map? 504 feet. So I'm a little higher up, and put my tripod down. Look at this beautiful water. All right, let's zoom. Please, putting the tripod down. Okay, you're looking stable. My altimeter says 22 feet, which makes sense. Oh, it jumps up to 39 feet. Huh, it just measures the altitude out of thin air. And I get gusts of wind blowing at me, if you want to hear the sound. It's windy. And at that height elevation, 22 feet or so, maybe 39 if you want, you can see a fair amount of the top of our pu'u. You're not supposed to see anything below 500 feet if my camera eye was on the ocean level, but I went up 22 feet. And I can clearly see the top. You can see clearly below 311 feet at our distance, or what, 27 miles or so away? You can see there's a gap between the slopes of Hualalai and Pu'u Ku'ili as if it was an island. You got it? Altimeter says 22 again. It's going to remain at 22. Yoo-hoo. I'm not pressing any button here. Should I remove my thumb away from there? Remove it. See? Skip to 39. And the button I press is the set button. Has nothing to do with changing the elevation manually. So I'm going to climb up the rest of this little slope. Get off of those rocks. See the lighthouse. So my ground level is just under 30 feet. Remember the elevation website. I'm just below that. Now you can hear the wind whipping. Turn the volume down. Okay, now my altimeter says 55 feet. So it jumped way up. Remember the grounds, as we checked on the website, right around the lighthouse, it says 30 feet. And I'm just below that. Look at the beautiful water. Look at that. No sharks in sight. 52 feet, 55. And we're still looking at our Pu'u Ku'ili by the Ellison Onizuka Airport. And it still looks like it's an island. It's separated. So we don't see the grounds there at 213 feet. But we can clearly see the top at 311 feet. And below. You can see almost 100 feet lower. So just skip along a tiny bit, move up, see it's still at 55, and get closer to the lighthouse or even a little bit higher up, a little bit above it. See, right above it. Didn't change much on my altimeter. I'm going to be looking in between the trees here. Altimeter says 62 feet. I did go up, or it says 55. I didn't go up that much, 59, whatever you feel like. 62 now. Okay, but remember, the elevation finder website shows me that I'm just over 30 feet. Still looking towards our Pu'u Ku'ili. And I won't say the name. And it almost looks like we can see the grounds at 213 feet of elevation. Is that right? How come I'm a little blurry right now? I'll take time to focus because I'm on manual. And my altimeter says 59, 62, 59, 55. Okay, so I made the grounds of 213 feet appear, and we're not supposed to see anything below 500 feet. And I'm just like 30 some feet according to the elevation finder, and according to my altimeter, I'm about 60 feet. So there's a lot of numbers missing here. Okay, now I went up a little bit higher on the hill, very bit, only a little bit higher. It only says 65 feet, so I didn't make much improvement. You can see our lighthouse is behind the trees here. And I'm gonna go up this small hill here after that. You see the Kohala Mountains, Mauna Kea, Mauna Loa, and Hualalai Mountain. And you can see Lapakahi State Park. See some boats trying to race here. Okay, that's not my point. Come on, Louis. Stick to the point. All right, now we can see, according to my altimeter, I didn't go up much at all. And we see a whole lot more land, a lot more grounds appearing here. And we're not supposed to see anything below 500 feet. And I'm up at 660 some feet, and I can clearly see 213 feet. I can clearly see 311 feet up there. And I'm almost like 50 feet lower than this level here. Okay. Let's skip to the next one. Climb a little further. Still above the lighthouse, you saw. And zoom in. Excuse me. So you can clearly see 213 feet of elevation. It almost looks like we're 100 feet lower here, and I didn't climb much. Zoomed out. Lighthouse is still there. We have an elevation, 85 feet. 88, 85. Okay, now we're going to go up a little higher. $101 according to my altimeter. And still looking towards our Pu'u Ku'ili. Turn the volume down. You can hear how windy it is. So the height here is pretty much the same height as here. So we see like at least 200 feet of grounds here, and I'm only at 100 feet. Okay, so therefore, at our distance, we're hiding about only 300 feet, and we're supposed to be hiding 500 feet. How accurate is that? Mr. Robert? Robert the expert? You can almost see some resorts here on the shoreline. All right, next one. Gusty, 144 feet, according to my altimeter. And now I'm on the top of this little plateau. And there's Lapak. Okay. So I'm touring the mountains here. There's Mauna Loa, the biggest mountain on Earth. Next to Mauna Kea, the tallest mountain on Earth with the biggest gathering of telescopes to observe fake space up there. And they want to stick another one, the TMT, against the will of the native Hawaiians up there. They've been trying for years to get their 30-meter telescope up there. Here are the Kohala mountain tops. Okay. And we're looking at Kualalai Mountain sloping down to the ocean with Pu'u Ku'ili sticking out. Let's see what we see at 20-some miles away, and I'm at 140-some feet of elevation. You can see a lot more of the coast, but we can't necessarily see the shoreline. We see resorts that were barely visible. You see those 3 buildings here. Remember those 3 buildings when I showed you in the first clip on the highway going up to Waimea above Spencer Beach Park? So we're making almost the grounds, all of the grounds appear, and I'm only at 140-some feet of elevation. 137 it says. Didn't change. All right. About this one. That's not the one. This one here. So I'm at the entrance of the park. Why is it closed? Why? Why are you keeping us away from a healthy environment? Because of what? You don't want me to go in the sun, in the ocean, where nobody else goes? Because of what? 150 feet, 154 feet. Remember our elevation finder here. It says 124 feet. I'm right here in this parking lot. Okay, and my altimeter says 154 feet. So it's giving me 30 more feet. It measures out of thin air. I don't know how the elevation finder guys got their measurements, their data, but who knows? Who can go out there with a ruler and measure that? Because when I measure anything in my hand that's small enough to fit in my hand, I really have to line up my eyeball on both ends of what I'm measuring to get an accurate measurement. Because if I don't move my eyeball, I'm too lazy to get my eyeball to be very lined up with really well, I'm not going to get an accurate measurement. Therefore, if I need to cut something, I might need to cut it a few times because I'm too lazy to become accurate. So here at 125 feet, according to the elevation finder, or 154 feet, according to my altimeter, we can almost see the shoreline. Do you see the shoreline? It almost looks like it's sticking out here, because this is a little further than our Pu'u on the coast. So we might be able to see that part of the shore, but we can't see anything closer. Alright, it's close enough. How far are we from Robert's mat here? Hey, Robert. 154. Where do you get your numbers, Robert? Where did you get those numbers? Does that really make up our put us on a globe spinning in space? I don't think so. Anyway, thank you for your time for today. I got more proofs, like I say. Please keep on watching my videos. Curvature Amateur, either on BitChute or YouTube. Aloha.